Hi again. So this is our last practice problem for test 2. It is about quadratic functions and identifying the vertex in quadratic functions, x-intercept, y-intercept, and drawing that quadratic function. So here's the problem. The quadratic function is given here, negative quantity x plus 2 squared plus 9. All right. So the first question is determine the vertex that f of x. So we know that by heart at this point. I'm hoping this is the vertex form, or we call it transformation form of the quadratic function. So what do we see here? Plus 2. So then plus 2 will be equal to negative h. That's the part that you need to be careful. Right? So then h will be equal to negative 2 and k will be equal to 9, so you can take it as is. So the vertex will be at negative 2, 9. All right, so the tricky part here, you might read the h as 2, but it will be negative 2 because it's in original form. That's as x minus h. So here it's given as x plus 2, so you need to consider the sign. All right, part B, determine the x-intercepts. So remember, the x-intercepts are where the function is equal to 0. So you're going to go ahead and make that function equal to 0. Why is this problem different in terms of x-intercept? Because by using the quadratic formula, we know how to find the x-intercept of the standard form, ax squared plus bx plus c. However, this function is not in standard form. It's in transformational form or vertex form. So there are multiple ways for us to be able to find the x-intercept. I'm going to choose way 1, and I will also show you the quadratic formula. So but this definition is not going to change. Function will be equal to 0 at the x-intercept. So we're going to take that function, negative x plus 2 quantity squared plus 9 equal to 0. Okay, and then let's add some steps here. Okay. Just a second. It's gonna take longer than, right? Yeah. All right, then move 9 to the other side. So negative x plus 2 quantity squared will be equal to negative 9. Rewrite it, x plus 2 quantity squared equals 9. Take the square root of both sides. Okay, then x plus 2 equal plus 3. Or x plus 2 equal negative 3. Remember the discriminant, you might have 2 roots. So then by subtracting 2, we're going to have 1. And we're going to have negative 5. So this is first root, this is the second root. All right, so this is way 1. Way 2, you can take that function, open it up, write it in standard form, and then find the roots. Then what we're going to do, rewrite, still need that extra spot. Oops. So function was f of x, negative, that quantity will be opened up as x squared plus 4x plus 4 plus 9, and f of x will turn out to be negative x squared, negative 4x, negative 4 plus 9. And then it will become, clean up the terms, as f of x is equal to negative x squared minus 4x plus 5. Okay. So you can apply the quadratic formula, you can apply the factoring skills. If factoring doesn't work, you need to apply the quadratic formula. which you might need to in the exam. So you identify your A, B, and C's. And then we will write down x12 equal to negative b, which is 4, plus or minus b squared, 16, minus 4, parentheses, negative 1, use it this way, parentheses 5. So everybody is in square root here, all over 2a, which is negative 2. So we're going to deal with this. Particularly, I'm doing quadratic formula in this case. You might well do the factoring, but I want you to see how to write in the square root form when you're writing b squared minus 4ac. Use the parentheses. It's so easy to make mistakes with those negative signs. So plus or minus square root. Okay, so negative 4 times negative 5. So that will be 20, 36. Okay, all over negative 2. Square root of 36 will leave the square root as plus or minus 6. So first root will be 4 plus 6 over 2. Second root will be negative 2. 4 minus 6 over negative 2. Right, so that will be 10, negative 2. That will be negative 5. That will be negative 2 over negative 2. That will be 1. I believe we have the same roots there. Okay, so again, you can do factoring. The reason I've done the quadratic formula here, I also wanted to share, we are so prone to make mistakes that b squared minus 4a times c. Just pay attention and write them down in parentheses, please. All right, so these are the x-intercept x values. So the complete answer will be negative 1, 0, and 5, 0. All right, y-intercept. Y-intercept happens at f of 0. And then that will be, what was the function? Yeah, I can see that on my notes. Negative 0 plus 2 squared plus 9. And f of 0 will be equal to, so 2 squared is 4. That will be turn out negative 4 and plus 9. So f of 0 is equal to 5. Be careful with the negative sign up front. And then y-intercept will happen to be x0, y5. Okay, make sure that you're giving the point forms. All right, now we're going to draw that. So let's do this. We do have a vertex at negative 2, 9. That was our vertex, 2, 9. Right, important points. We did have y-intercepts at negative 5, 0, and 1, 0. So 1, 0, negative 5, 0. So this is not a point actually, this is just there to show my vertex and coordinate values. Okay. And then we also had an y-intercept which is 0, 5. Y-int, that was x-int. Okay, so 0, 5, that's here. So we want this function to be passing through these points. Probably it might be a good idea to show the axis of symmetry, right? It's at h value, x equals 0. You don't have to, but that's it. All right, so moral of the story. You're using the points that you have found in the parts before, vertex, x-intercept, and y-intercept. Be careful writing down your final answer as x-intercept and y-intercept. They are point values. We might need to use the quadratic formula. Be careful as you're using the quadratic formula. After you identify your terms, A, B, C, use the parentheses. Negative 4 times parentheses A, parentheses B. Parentheses C. So that's like negative 5 times negative 4. That's how it becomes plus 36 here. I don't think that we have good examples in the lab manual asking us the x-intercept if the function is given in transformation form or in vertex form. Make sure that you open it up, bring it into the standard form, then identify ABC and apply quadratic formula, or as you see in this way, maybe we might have a k value here easily can be, square root can be taken. You can prefer that way, but that's not a guarantee. You might end up with an ugly number here. So be careful with that. And that's all I wanted to say. See ya.